Python multiprocessing memory usage. I have written a program that can be summarized as follows. The real code, especially write output, is a lot more complicated. Write output only uses these values that it takes as its arguments, meaning it does not reference data. Basically, it loads a huge dataset into memory and processes it. Writing of the output is delegated to a subprocess. It writes into multiple files actually, and this takes a lot of time. So each time one data item gets processed, it is sent to the subprocess trough resonator queue, which in turn writes the result into files as needed. The subprocess does not need to access, read or modify the data loaded by load_huge_data in any way. The subprocess only needs to use what the main process sends at trough resonator, and this leads me to my problem in question. It seems to me that the subprocess gets its own copy of the huge dataset when checking memory usage with top. Is this true? And if so, then how can I avoid ID using double memory essentially? I am using Python 2.6 and program is running on Linux.
The multiprocessing module is effectively based on the fork system call, which creates a copy of the current process. Since you are loading the huge data before you fork or create the multiprocessing process, the child process inherits a copy of the data. However, if the operating system you are running on implements cow copy on write, there will only actually be one copy of the data in physical memory unless you modify the data in either the parent or child process. Both parent and child will share the same physical memory pages, albeit in different virtual address spaces, and even then, additional memory will only be allocated for the changes in page size increments. You can avoid this situation by calling multiprocessing process before you load your huge data. Then the additional memory allocations will not be reflected in the child process when you load the data in the parent. Edit. Reflecting at Yana Kurila's comment in the answer, as it is so relevant. Note also that every Python object contains a reference count that is modified whenever the object is accessed. So, just reading a data structure can cause cow to copy.
As recommended in the documentation, explicitly pass resources to child processes. I would make the large data, explicitly, global, so if there is copy on write, cow, available and you fork new processes. In macOS it is spawned by default nowadays. The data is available in the child processes. But keep in mind that Python data structures are copied. You would need to some more low-level data types such as numpy because of Python GIL.
Ironicamente, precisamos de área and the problem.